Okay, you guys, let's look at number 15. So number 15 is telling us that we have a 0.25 molar solution of a weak acid with a pH of 4.55. And then first it wants us to find the Ka value for this acid solution. So again, it's telling us that it's a weak acid, so we know it doesn't dissociate 100%. And so we're going to need to start by writing a Ka expression. This is another situation where it doesn't give us the actual weak acid. So we're going to write the generic Ka expression. So we've got our hydronium and conjugate base on the top, and we have our acid on the bottom. So what do we know about this? We know for sure that we have a pH of 4.55, and the pH is found from the negative log of the concentration of hydrogen, which is our hydronium ions here. And so if we undo the negative log, so to undo the negative log, we're going to take 10 to the negative pH. So 10 to the negative 4.55 gives us 2.8 times 10 to the negative fifth molar. So that's our concentration of our hydrogen or our hydronium ions. Now, because we can assume that this is a monoprotic acid, that's all that we've worked with, this is going to be a 1-to-1 ratio. So for every one hydronium ion that's created, one conjugate base is created. And so what we can say on the top of our Ka expression is that we're going to square that hydrogen concentration. So that's our hydronium and our conjugate base. And then we're going to divide it by the concentration of our acid that we were given. So when we do that math, we get a Ka value of 3.25 times 10 to the negative ninth. Now it says it's a weak acid solution. It has a pretty high pH for an acid, and so I would expect this Ka value to be a really low value like this. So 3.25 times 10 to the ninth is a really weak acid, but that makes sense from what our pH is. So you guys always check that your values make sense and that you are checking those relationships. If I was going to calculate the Kb, I would expect to have a much higher Kb because they have to balance each other out. If the acid is really weak, its conjugate base is going to be a little bit stronger. So finally, then it's asking, what's the percent ionization of this acid? Now, by definition, it's a weak acid. With the Ka value, we know that it's a really weak acid, and so I'm not going to expect this ionization percent to be very high. So first we've got our equation. It's going to be the concentration of hydrogen ions, so the part that actually ionizes, divided by the concentration of the whole, our whole acid, times 100 to get it to a percentage. So we're going to plug in our value for hydrogen that we found by taking 10 to the negative pH. And then our acid concentration was given to us. And when we do our math, it's a super small value, percent ionization of 0.011%. So again, super weak acid, I would expect that value to be pretty low.